right, we're moving along here to angle measures. So we've done quite a few angle stuff right now. We've done our central angles. And now we did our inscribed angles. So now we're going to do a couple more here, dealing with different types of stuff. We've got, secants and tangents that also form some new lovely angle measure relationships. So let's go ahead and jump into it. All right, here's our first one, dealing with a tangent and a chord. So if a tangent, remember those are the ones that hit one time, and a chord intersect at a point on a circle, then the measure of each angle is formed is 1/2 the measure of intercepted arc. Okay, so you should have this picture in your cheat sheet. So let's just write down that extra stuff there. So what this is saying is that we have ourselves a tangent, which is this guy right here, and we have a chord that's hitting. It's kind of like an inscribed angle, except the other one is not on the inside, but whatever we have, the arc AB here is going to be equal to double this, or to find the measure of angle 1, I'm going to take this and cut it in half. Angle 2 is the same way. Okay, so whatever this arc is, I'm going to cut it in half to angle 2, or take angle 2 and double it to get that arc. There are going to be some times where I might give you the other one and ask for the other one. Well, remember, these guys add up to 180 because it's going to be a linear, okay? Because it's not going from here to the circle, it's going from here down to the tangent, okay? And then these two have to add up to 360. So just keep that in mind when we're doing that, okay? So angle 1 is half of arc AB, and angle 2 is half the measure of arc of BCA. Let's do an example using that exact knowledge. We're going to find the measure of the arc RST. Well, what I know is that RST is double whatever the angle TRM is. Since this angle is half this way, to go the other way, we're going to double it, kind of like we do with the inscribed angles. So we're going to do 2 times 102, and we get a total of 204 degrees. Okay, and that's it. Let's do one now with variables. And the relationship here is that I know that this angle here, angle CBD, is going to be half of the arc BAD. And so we can either do 2 times 5x, or you can do 9x plus 20 divided by 2. Now, I like to double things because I'm dealing less with fractions, but you can always take this 9x plus 20 and multiply that by 1/2. Okay, so doubling the 5x is the way I'm going to go. So 2 times 5 is 10, so I get 10x, and then now it's algebra. Subtract the 10, get x, so we know the value of x is 20. However, I'm not done with my problem. I want to know what the angle CBD is, so I need to take that value and substitute it back in. So 5 times 20 is 100 degrees, which means that arc there is 200 degrees, which means this arc down here is going to be 160 degrees, because it's 360 minus 200. Okay, hopefully you followed that train of thought. All right, on to our next one. So the last one was a tangent and chord, and this one is dealing with 2 chords. So now we're on the inside of the circle. The last one was on the circle. This one is inside the circle, made up of 2 chords. What that is it's the measure of 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. All right, so what does that mean? So if we're going to find something like angle 1, okay, angle 1 has a vertical angle with this guy over here. So essentially, let me go ahead and draw in a number 1 right there. So there's like a 1 over here. Those guys are equal. And then there's like a number 2 right there. Okay, sorry, that's an awful 2. Okay, so these guys are equal to each other, and these guys are equal to each other. If I want to find the measure of one of them, I would take the 2 intercepted arcs, so arc DC and arc AB, and the sum means to add them together. So I'm going to do that plus that, and then cut that in half because of that half there. Okay, so let's look that in some words here. So angle 1 is 1/2 the arc DC plus arc AB. Okay, so we're going to add them together and cut them in half. Angle 2 is going to be found the same way, except there's the 2 other arcs. So AD plus BC is going to be the measure of angle 2. Okay, so that's what we get right there. This is different than a central angle. This is meaning anywhere in the middle. So technically, we could do it if we're dealing with a central angle, but we probably wouldn't want to. Okay, you can find things a lot easier there because it's equal to measures. So this is when we're dealing with things that are not central angles. It's found anywhere randomly throughout our circle. Okay. All right, let's look at example 3 using that same kind of process. To find x, I know that PS is equal to 106 and arc QR is equal to 174. And so to find x, I know it's the sum of those 2 arcs together and then cut in half. So I'm going to set it up as x equals 1/2 measure PS plus RQ, or 106 plus 174. So I'm going to add them together and then cut them in half. Okay, so you see the difference between this and the last one? In the last one, we're just cutting things in half, kind of like inscribed angles. In this one, we're going to add them together and then cut them in half. But this is different than our final one. So the final one is dealing with angles that meet on the outside of the circle. So we had on the circle, the last one was in the circle, and now we're meeting on the outside of the circle. And there are a couple different cases with these because we're dealing with tangents, two secants, or a tangent and a secant. And so these all have the same exact the process to solve them, but I want to show you each of them. Okay, so this is a tangent and a secant, and essentially what we're going to be doing is always farthest arc from the angle, so this one is angle arc BC, minus the closer arc, so arc AC, divided by 2. So farthest minus the closest divided by 2. This one here is two tangents, but the process is exactly the same. We're doing the arc that's farthest, which in this one is PQR, minus the closest, which is PR, divided by 2. Now keep in mind here, since these are two tangents, these two angles together represent the entire circle. So that's something to kind of keep in mind as we move forward through some of these problems. And then finally we have our two secants, but it's the exact same process. We're talking about the farther arc, or XY, minus the closer arc, or WZ, and then cutting that in half. So that's the same thing for all of them. Farther minus the closer divided by 2. So let's use that. So in this one here, I'm trying to find the measure of that arc X, okay, which is represented by X. So we can find different things. I could find what this arc is here. I could try to find what this arc is down here. I could even find this arc over here if I really wanted to. You would just have to find what that is and subtract it from 360. Or I could find the measure of that angle. So make sure you're paying attention to what it is that you're looking for. So in this one, I'm trying to find that angle. So the relationship is the angle equals the farthest, which is 200, minus the closest, and then times a half. Now you can distribute through with the 1/2. I like to multiply the other side by 2. I like to deal with that more than I like to deal with the 1/2 in fractions. So 144 is equal to 200 minus x. Subtract the 200 from both sides, and then divide by -1. So the value of that arc there, that x, is going to be 56 degrees. Let's do another example here. So this one is dealing with the two tangents. And what I can see is I see that this one here is a 92 degree, the arc AC, but I don't have arc ABC. And so that's what I was talking about before. Since I have myself two tangents, I know that the total of the circle is going to have to be 360 degrees. So if this is 92, I can find arc ABC by doing 360 minus that 92. Okay, so ABC's arc is 268. So we got to do a little bit more work here before we can jump into solve for that value of x. Okay, so now I know what the two arcs are. I'm going to do the farthest minus the closest. So 268 minus 92, and then I'm going to cut that in half. So 268 minus 92 is 176, and then dividing that by 2, I get 88. So the value of x is 88, or that angle there is 88. Okay, why don't you go ahead and hit the pause button and try this problem now for yourself. Okay, let's see how you did. So to find angle 1, since it's a tangent and a chord, it's meeting on the circle, I'm just going to take its intercepted arc and cut it in half. So for this problem, just 1/2 times 150. So you should have gotten the measure of 75. Let's take a look at this one. Go ahead and try this one out now. Okay, so for this one, this is dealing with two chords. That means we're going to add them because they're meeting inside the circle. So 40 plus 120, and then we get 160. Cut that in half. You should have gotten 80. Let's do one more. This is a toughie. I want you to know that now. Go ahead and give it a try. Okay, hopefully you did give it an honest try here. This one is a little bit tougher. We're talking about a satellite, and it's orbiting the Earth, and we want to know what the viewing angle is. So some people are not really sure what it means by viewing angle. So if this is the satellite, it wants to know what can it see on the Earth. Well, the piece that it can see is going to be this piece right here. So that's what I'm trying to find out. So I don't know what it is, so I'm going to use the value or the variable x as my unknown. Well, I know that these guys are two tangents, and we kind of talked about this for a little bit. If this measure here was, say, 30 degrees, I would find this other portion by doing 360 minus 30. Well, in this case, I know that this is x, so this is going to have to be 360 minus x. So if you didn't understand that before, now you have a little bit of a setup. Go ahead and try to solve for x now. Okay, so let's see how you did. We know that the angle, or 17.5, is equal to 1/2. 360 minus x is the farthest, minus the closer one, which is x. So when I distribute through or combine our like terms inside there, 360 minus 2x, and I doubled the 17.5 to get 35. So now I'm going to subtract 360 and divide by 2. And we got 162.5. If you have no idea what we just did there, please make sure you ask your teacher for some help. And that's all for this video. Go ahead and start working on that practice.